Hi everyone and welcome back to the session. I am Sobhagya, currently working as a software engineer at iMesh. In today's session, we will be installing Cilium on AWS in standalone mode with ENI, that is Elastic Network Interface enabled. Now let's take a quick look at what we have planned for today. Today, first we will start with a quick recap of routing mode and IPAM, and then we will move straight into the demo to install Cilium in ENI mode. Now, moving to the first item on our agenda, let's briefly recap what we learned previously. To understand today's installation, we need to clarify two main concepts, routing mode and IPAM. First, routing mode. To simply put, routing is just how we send our packets from one pod to another. There are various methods to do this, like using tunnels or overlay. Second is IPAM. This simply refers to the way we are giving an IP address to a pod. There are various ways we can assign these IPs. However, for today, we will use ENI mode for both routing and IPAM. By doing this, we are effectively telling Cilium to assign actual AWS ENI IPs to our pods. This is crucial because it allows us to use native routing, meaning Cilium will use the underlying AWS infrastructure to forward packets natively, completely eliminating the need for a tunnel or overlay network. Now moving to the second item on our agenda, the installation demo. To keep things organized, we will cover this process in four main steps. First, we will check the requirements for running Cilium in standalone mode to ensure our environment is ready. Second, we will create the cluster. This involves applying both the cluster configuration and the node group configuration. Third, we will apply the Helm charts to actually deploy Cilium into our environment. And finally, we will perform connectivity tests to verify that our networking is functioning correctly. Now moving to the first step of our demo, the requirements. We can break this down into four key points. First are the general requirements. These are your standard prerequisites, ensuring you have the correct Linux kernel version, the necessary IAM roles for AWS, and common tools like kubectl and Helm. Second, and most importantly, we must disable default AWS add-ons. We specifically need to disable AWS Node, which is the default AWS VPC CNI. Since Cilium will act as the sole CNI for our cluster, we must remove the default one to completely avoid any conflicts. Third is enabling private networking. We need to set private networking to true in our node group configuration. This is critical because without it, we have seen Cilium connectivity tests fail due to reachability issues. Fourth is the Cilium startup taint. This configuration ensures that your application pods do not start until the Cilium agent is running and the node has been assigned an IP. While this is optional and not necessary for a fresh cluster, it is a recommended best practice to prevent race conditions during startup. Now we move to step 2, creating the cluster. We will handle this in two parts using eksctl. First, we apply the cluster configuration. As you can see in the configuration on the left, we are setting up the basics like the cluster name, region and version. Notice that we have set disable default add-ons to true. As we discussed, this prevents the standard AWS VPC CNI from installing. Second, we apply the node group configuration. On the right side, you can see node group manifest. This is where we enforce private networking true and add our Cilium startup taint. A quick note on IAM permissions. You will notice we have listed specific IAM policies here. However, it is worth noting that if you are using eksctl, you don't explicitly need to add this IAM field. eksctl will auto-populate the node group with the necessary default policies if you leave it out. We have just included it here for clarity. So we will now apply these manifests one by one. First we create the cluster and then we create the node group. Once the node group is successfully provisioned, if you check the status of your nodes, you will notice something interesting. The node state will be stuck in not ready. Do not worry, this is completely expected. Since we disabled the default AWS CNI and haven't installed Cilium yet, our nodes have no networking plugin to handle traffic. This is exactly where our next step comes in. Moving to step 3, deploying Cilium. We will now install Cilium using Helm with specific flags. We run helm install setting ENI enable to true and IPAM mode to ENI. This explicitly tells Cilium to use the AWS network stack. Once this finishes, if you check your nodes again, you should see them transition to ready. Finally, we reach step 4, the connectivity test. To be absolutely sure everything is working, we run the Cilium connectivity test. This verifies network reachability across the cluster. So that concludes the theoretical overview. We have mapped out exactly what we need to do, from the prerequisites to the final tests. Now it is time to turn that theory into action. So now let's move to the terminal to do this practically. Before we start typing commands, I want to mention a quick improvement from our last demo. You might recall I mentioned that when performing connectivity test from a local machine, the network ping can be quite high, which causes our test time to increase significantly. To minimize that latency for this session, I am using AWS Cloud Shell directly. Since this runs in the same region as our cluster, the latency is negligible, giving us much faster test completion time. As you can see, I am already logged in, so let's get started. Since this is a fresh Cloud Shell instance, we don't have the Cilium charts installed yet. So the very first thing we need to do is add the Cilium Helm repository. We run helm repo add Cilium https://helm.cilium.io. And just to be sure we have the latest versions, we will follow up with a quick Helm repo update. Now that our repo is added, let's move to the installation. First, we will create a dedicated namespace for Cilium to keep our deployment organized. We simply run kubectl create namespace Cilium system. With the Cilium system namespace created, we are now ready to execute the deployment command. As you can see on the screen, I am pasting the helm install command. Note that for this demo, we are specifically targeting Cilium version 1.18.4. Let's take a moment to break down the flags we are passing here, as they are the key to making standalone mode work. First and most importantly is set ENI enable to true. Think of this as the master switch for AWS compatibility. Setting this to true ensures that the AWS specific Cilium operator image is deployed instead of the generic one. It also enables the automatic creation of necessary node resources and configures various background settings required for Cilium to run smoothly on AWS. It is crucial to note that if you only set the IPAM mode to ENI without this ENI enable flag, the standard operator will not function correctly. You would typically see errors in your agent logs and Cilium would fail to become ready. Next, we have set IPAM mode to ENI. As we discussed during the recap, this flag configures Cilium to handle IP address management by assigning native AWS ENI IPs directly to our pods. And finally, set routing mode to native. This works together with the IPAM mode, ensuring that Cilium utilizes the underlying AWS infrastructure for routing packets natively rather than using encapsulation like VXLAN. Now we are running the command and waiting a few moments for Cilium to fully deploy. Now that the deployment has been applied, let's check Cilium status to verify that everything is running correctly. Now everything is okay. Let's check all pods manually. Now that all looks good, we can move to connectivity test. Before we finally run the connectivity test, let's circle back to something I mentioned earlier. You might remember that before installing Cilium, our nodes were stuck in a not ready state because they lacked the CNI to handle the networking. Now that Cilium is successfully installed, let's check the nodes again by running kubectl get nodes. As you can see, the nodes are now fully ready. This confirms that the networking layer is active. It also means that critical system components like core DNS, which were previously pending, have now successfully received their IPs and are running smoothly. So, with a healthy cluster and ready nodes, we are set for the final step. Now that we are all set, let's run the final connectivity test. I will execute Cilium connectivity test. One important thing to note here, you might remember in our previous demo where we used chaining mode, we had to exclude certain test cases. However, for this session, I will not exclude any tests since we are running in standalone mode. Cilium has complete control over the entire data path. This means we expect full compatibility and shouldn't see the failures that can sometimes happen when chaining on top of another CNI. The test will take a few minutes to complete, so to save time, I will pause the video and I will see you all at the end of the video with the results. Welcome back. Our connectivity tests have now finished running. As you can see on the screen, all test cases have passed successfully. And remember, unlike in chaining mode, we did not exclude a single test here. This really demonstrates the stability and control we get by running Cilium in standalone mode with native AWS routing. So we can close this session here. Thank you so much for watching. If you have any questions or run into any issues during your installation, please feel free to ask in the comment section below. We'll see you in the next session. Bye and have a nice day.